Welcome, everybody. I'm Jerry Eschbaugh, and today I'm going to be talking about containerization of Postgres. So, quick outline of what we're going to be covering today. First, what is a container? When to containerize Postgres, and when you might not want to. Like any technical solution, there is no one-size-fits-all, and understanding the strengths and weaknesses of any technology is a key to implementing the right strategy going forward for your organization. I've been working on flood insurance modernization for FEMA for 3 years now, and I'm going to give a brief overview of that actually right now, and then we'll talk about lessons learned and best practices. And this modernization project, like most government modernization projects, was taking something that had been in production for many, many years, and we took a greenfield approach to this instead of, trying to migrate systems and technology. Like, what's a good modern architecture that we need to put in place that's going to serve flood insurance for the citizens of the United States for many years to come? And we came up with OpenShift as a containerized platform, and containerizing Postgres, of course, and other databases and other technologies as well. And we'll be sharing some lessons learned and best practices here towards the end. Talk a little bit about the road ahead. This is by no means done as far as this journey. Containers are still fairly new to most people, and there's a lot more work we can do in the federal and public spaces as well. And then finally, we'll end with a demo of getting started with containerized Postgres and show you how easy it is to get started and actually start using Postgres running in a container. But first, a little bit about me. I am a progressive technologist. Always been kind of on the leading edge of new technologies. I was working in robotics back in the 80s, in virtual reality and simulation in the 90s, and artificial intelligence in the late 90s. And more recently, been working with containerization. And it's been really exciting, and DevOps and pipelines and all those things that really help deliver value to our customers faster. One thing I learned very early as being a bit of a futurist, a bit of a progressive, is that anything you come up, anything new, isn't going to work well for your end customers unless you really focus on the ilities. And if you're not familiar with these, there's probably about 20 of them. This is just a short summary, but it's thinking about testability, reliability, maintainability, scalability, security. And this is what separates a junior DBA from a senior DBA, in my opinion, or a programmer from a software engineer. Is really their focus on these other aspects of technology. I'm currently working as a DevOps practitioner, somewhat of a recovering software developer, although I still love developing new projects and writing code, architect, and an accidental DBA. Most people attending this probably know far more about Postgres than I do, and I've actually been very fortunate enough to build a great team here for the federal government, and surrounded myself with some really awesome people. One of my favorite Michael Dell quotes is, "If you're the smartest guy in the room, leave." And I think I'm going to be with this team for quite a while, so it's really great to work with such smart people. And my current roles and responsibilities: I'm a DevOps lead on FEMA. Actually got my start with relational database management systems with Confio, working on the Ignite product. I don't know if you recall that from the Oracle days. It's now called SolarWinds DPA. But that was a great experience to get exposure to relational databases and response time analysis, which is really the key to improving performance. Also, on the side, I work as a strategic advisor through my own LLC, so the strategic product, working on DevSecOps, large mergers and acquisitions, and cloud architecture and best practices. So my journey with containerization started in 2015, and we were working with MySQL and websites, and that's a great place to start because with websites, you tend to have a lot of layers of caching between your database and your customer. So if things didn't work, which happened on occasion, sometimes people wouldn't even notice. So it was a really great exposure to containerization getting started. We started off with 2 containers. We had MySQL running in a container, very much like I'm going to show you Postgres running in a container at the end of this presentation. And then we had Drupal, which is a LAMP stack with PHP, running in another container. Quickly, 2 containers turned into 20, turned into 200. we realized we need something to manage all this and discovered orchestration. And we started doing do-it-yourself orchestration using Salt Stack and Docker Compose. Salt, if you're not familiar with it, is similar to Ansible or Puppet or Chef, but realized there's got to be a better solution out there. And kind of went down a dead-end alley. We selected a product called Rancher. And at the time, Rancher was still cattle-based, which was not Kubernetes orchestration framework. It actually worked quite well for our use case, but there wasn't a long longevity for that. This was the middle of the container orchestration wars. Kubernetes has won that war. Kubernetes is a technology that was developed by Google, and if you are going to use container orchestration, highly recommend it's Kubernetes based, and it'll be hard to find anything today that's not Kubernetes based. So that's the great news. Even Rancher converted over to Kubernetes. More recently, back in 2017, started working on this flood insurance modernization. We were able, thanks to containerization, to very quickly spin up a proof of concept and deliver that to our customers to show what is possible. Then once again, a little bit of a red zone here is we went down the road of OpenShift for container orchestration using EFM, PG Pool, full clustered stack, and had a lot of problems with what I call the two-headed monster syndrome, with EFM fighting Kubernetes and PG Pool fighting some of our schema migration technology, and very challenging times in this program. And went back to the basics. We went back to OpenShift, what I called simple EDB, using read-only replicas, and that's working very well even today. We're able to deliver at scale, and we don't have the issue with EFM fighting with Kubernetes. In the future, I'm very interested in what EDB is working on with their containerization. Very excited that one of my colleagues, Rob Vanderville, is now on the team there at EDB. Super sharp DBAs. So looking forward to what's coming with EDB's containerization and hopefully moving over to that here in the near future. So what is a container? A container is a Linux technology that encapsulates the application and the server configuration in a lightweight package. Technologies that a container is built on are not new. Namespaces have been in Linux for many years. And they isolate the process IDs. So if you go inside a container and you do a ps-ef, you're just going to see a few processes running, sometimes only one. That's the processes that are inside that container. If you go on the host, you're actually going to see all the processes running for all the containers. Namespaces also encapsulate network and storage mounts. Then there's C groups, and C groups are kind of like the governor that provides resource limiting, prioritization, and control. In addition, just like Postgres is a whole ecosystem of technologies that have been built around a fundamental database, there is a whole ecosystem of technologies, and I've already mentioned a few of them, like OpenShift from Red Hat and Rancher from Rancher Labs, Docker. The list goes on, and this is becoming a very mature technology. One of the things that comes up quite frequently when you start talking about containerization is comparisons to virtualization. And when you spin up your first container, you're like, wow, this looks like a little VM. And it is and it isn't. And there's some very distinct differences between the two. And I'd like to contrast those here today. So virtualization was designed to maximize server resource utilization, whereas containers are designed to maximize security and flexibility. Life cycle of a VM tends to be months or years, where a life cycle of a container might just be a few minutes or a few days. Virtualization uses vMotion, if you're using VMware, to move VMs between hosts. Kubernetes is far more dynamic, and by running multiple pods, which are copies of sets of containers, you can quickly move from host to host, have multiple pods running concurrently all at the same time. A lot of advantages there, and it's far less disruptive. If you've ever been in the process of having your database vMotioned behind the scenes on you, you'll know that can be a very disruptive thing to have happen. Virtualization has a very slow startup time. You got to boot the whole OS. where containerization, if you're running a lightweight lightweight container operating system like Alpine Linux, I've had containers start up in milliseconds. So you can do on-demand scaling and scale things up just as they're needed. You don't even have to keep them running, which is great when you're running in the cloud. Virtualization is virtualization is both Windows and Linux and Solaris and any other operating system you care to run. It really doesn't matter. Whereas containerization grew up mostly around Linux. So running Windows workloads can be challenging. There's two projects I'm watching very closely because some of our Postgres scanning tools are Windows only, quite ironically. And we would definitely need a Windows server to run those. So watching one project is called kubevert. And then Red Hat's gone down a little different road, which is using a KVM inside of a container for the virtualization that's coming in OpenShift in the near future. Virtualization is really designed to benefit IT operations, whereas containerization benefits the end user and the application. Why would anybody want to containerize Postgres? I'm going to take a drink before we get into this. That is tea, by the way. Supports CI/CD pipelines with multiple instances. So if you're containerized, you can have a dev instance that's exactly like your prod instance. You don't have to have two big instances, one for pre-prod, one for prod, with multiple databases running inside of those. It also supports microservices very well. And this is a new trend that's kind of the opposite of the old monolithic applications where you had everything running in one large database instance. Security, as I mentioned earlier with C groups and namespaces, there's a lot of advantages, security advantages around containerization. Automatic scalability. You can scale up, scale down containers as needed. You can also support live multi-site deployments far easier than you can with running databases on VMs or on cloud. Also support multi-cloud. With Kubernetes, it's fairly easy to do a lift and shift. So if you want to move to AWS from an on-prem data center, that's fine. If you find out your AWS bills are getting too high and you want to move back to an on-premise data center, that's also fine too. Not trivial, but you have that capability to support multi-cloud. And it gives you that isolation from being tied in to any particular ecosystem of a web hosting environment. It can also eliminate the need for virtualization. We talked earlier, a lot of what the advantages we got from VMware or KVM or RHEL's VM have been eliminated now with containerization. You can streamline software updates. Updating Postgres database instance can be as easy as just labeling an image with your live deployment or your pre-prod deployment and having that, and Kubernetes will automatically update everything for you. Of course, you want to test and you want to make sure that, going from EDB 9.6 to 11.7 is not something you do ad hoc. But aside from the testing, the actual infrastructure to make that happen is very streamlined. You can treat databases as disposable. And this is a bit of a cultural shift. One of my favorite sayings is you want to treat your infrastructure like cattle and not as pets. And a lot of database instances, a lot of server configurations are frequently treated as pets. They're groomed, they're cared, they're tweaked, they're bathed. And maybe you don't want to bathe your server, but the whole idea here is that you have configuration as to how things are set up, persisting, ideally using GitOps. But the actual implementation and instantiating of that is done automatically and can be created and disposed of as needed. Also, with containerization, you minimize the impact of outages because you tend to have far more instances running. So if you lose a Joe's dev instance and Joe's on vacation, you're not even going to notice that. So a lot of less impact of an outage. Whereas if you lost your Exadata rack running Oracle and there's a whole bunch of databases running out, that's a major problem. So it really helps you containerize and minimize the impact of an outage. A lot of people are talking about the cloud. A lot of what the cloud is has been around for 20 years. To me, containerization and web services is the cloud. And people talk about running containers in the cloud. I would assert that containers are the cloud. So why would you not? There's a lot of advantages there, right? Why would you not want to containerize everything, including Postgres? Well, on the technical side, monolithic applications do not containerize well. Large database instances, you want to decompose this, and this should be part of any modernization effort, is to do a service decomposition and isolate your data and localize your data around web services. Legacy technology support. There's some technologies like PEM, for instance, that still is not easily containerizable. And vendors are working on improving these older technologies, but sometimes it's a bit of a roadblock. And you could theoretically containerize anything, but sometimes you don't want to. So I think a lot of the modernization efforts that are going on throughout the industry are going to make this become less of an issue, but right now this is an issue. And as I said earlier, containers have a less impact when they do fail, but with more database instances, your probability of having an outage is higher, or a configuration issue, or anything that can happen with a database. But those aren't the real challenges. The real challenges come back to people. Traditionalist mindset. A lot of people are very comfortable the way things are. One of my favorite quotes ever is I was at a launch event for .NET way back, and somebody in the audience stood up and told a Microsoft presenter, if you tell me, if I learn this new .NET thing, can you promise me it's the last thing I'll ever have to learn? And the presenter came back, he goes, sorry, sir, I can't promise you that, but I can promise you you've picked the wrong career. And we constantly have to be learning new things in this industry. And unfortunately, a lot of traditionalists are going to have problems finding jobs in the future, but it's still a roadblock. Fear and uncomfortable. I went through a Franklin Planner personal productivity seminar a while back, and they talked about learning new technologies or learning new anything. And you go from a point of where you're aware of something, then you're interested in something, and then follows uncomfortable. And this is when you're just learning some new technology or some new process. And this is where a lot of people give up, and persevering through that uncomfortable to a point where you're comfortable. And hopefully you get some muscle memory going where you don't even have to think about what you're doing. It just works automatically, is really, as humans, where we need to focus. But this is something that people, face when learning something new. And we all face it. Regulation and compliance in the government space. This is important that we are compliant. We meet the needs of our customers, and a lot of regulation is very, very well written. I would argue some regulation and compliance is totally useless in today's world. It was written for a different time and place, and working to update that and make sure that we have compliance and documentation and things in place is very important, especially if you work in finance or in the public sector. One thing with humans is when people don't want to do something, they're very good at coming up with reasons why not. So you can pretty much fill in the blank as to why what you'll hear as to why not to containerize Postgres. And I've heard many creative ideas. And a lot of those, it really comes down to just people's fear and lack of exposure. So we talked a little bit about Kubernetes and OpenShift, and I'm just going to go over this really quickly. But what is container orchestration? It manages the entire container lifecycle. It's software-defined everything. So you've got software-defined compute, network, and storage. All container orchestration platforms that I've used have a nice web console, so it gives you a nice front end. The definition is in Java. In JSON or YAML, so you can persist that configuration of your Kubernetes infrastructure in Git. And it also has a command line interface for those of you people like myself that like to type and tell a computer what to do, and APIs for integration with other systems. So a brief overview of Kubernetes. At the high end, you have a namespace, and this in OpenShift is called a project. And just kind of starting over to the right, you've got compute, network, and storage. And those are really the key software-defined technologies within a Kubernetes cluster. But the orchestration to the left is what makes everything happen and manages that. So you've got deployments that manage deployment of new technologies. Stateful sets are very important for containerizing a Postgres because they give you the ability to have repeatable names and configurations of pods when they scale up. We'll talk about pods here in a second. Replication controller will keep the right number of replicas of a given pod running. Operators are a newer technology that help you configure and deploy applications with ease. File mappings. So this containers, and if you're running a container in production, you don't want to run it as root. You don't want root enabled at all on that container. So file mappings give you an easy way to map files inside of the container. So for instance, if you have a Postgres configuration file that you need to change quite frequently, you can change that outside in Kubernetes, and then the config map will automatically put that in there. For your credentials, for instance, for configuration like port, username, password, that can all be saved in a secrets, using secrets in OpenShift. Kubernetes has similar ways to manage that technology as well. Under compute, compute is, you'll hear the term pod a lot in Kubernetes, and you can think of pod as a grouping of containers that need to be scaled together. So you might have a monitoring container that's a sidecar to Postgres, so it monitors Postgres, and then Postgres is doing its work, and you might want 1 slave or 1,000 slave pods running. And as you scale those up, you get both that monitoring sidecar and your Postgres container as one pod or one collection of work units. Networks, services is the network component to Kubernetes. So when you talk about a service, you're talking about how the communication happens inside of a cluster. And OpenShift has a feature called a route, which actually lets you map URLs to a particular service. So it makes it very easy to tie a URL to a particular service that then ties it to a pod. And then storage, finally, and this is a little area of a little bit of confusion, is typically when you get started, what you'll want to do is you'll want to create some storage on disk. For a simple example, you'll want to create a persistent volume, which is the mapping between Kubernetes and that storage on disk, and then a persistent volume claim, which connects the persistent volume to the pod. And those levels of abstraction give you a lot of flexibility, but it can also be a little confusing. So, some lessons learned on this project. One thing we've run into early, as I mentioned, is the Kubernetes versus EFM kind of split brain problem. So I used to have a picture of a two-headed snake on this slide. I took it off, but you've got Kubernetes trying to manage and fail over pods, and you've got EFM trying to fail over nodes, and those don't play well together. Same thing with vMotion from virtualization and Kubernetes. Once again, two things trying to do the same thing at the same time. And we've kind of focused on Kubernetes first, and these other technologies, when they can be well integrated, we'll use them, but if not, we don't. And then resource management. Kubernetes has its own way of managing resources. So does VMware. And getting VMware either tamed or totally removed from the stack is something that we're working on in the future. And one lesson learned on virtualization is, since everything is software defined, if you have no CPU, you have no software-defined network, storage, or compute. So it's bigger than just a CPU starvation problem. It is a network problem, or storage as well. Employ advanced Kubernetes features earlier. This was our first project with Kubernetes, and there were some lessons learned. First time using OpenShift, and actually my first time using Postgres. So a lot of things learned, definitely things we do better, and kind of dig into more of the advanced features earlier, like stateful sets, as I mentioned earlier, secrets, affinities, taints, and tolerances are suggestions that you give to the Kubernetes scheduler, much like you give to a database planner. So instead of telling it exactly what you want it to do, you can give it affinities or annotate affinities for a pod to tell this pod to avoid nodes that don't have SSD storage on the back end. Or you can say, I don't want these two pods to run together on the same physical host. So a lot of things you can do with affinities, taints, and tolerances. Do not do schema migration through pgpool. This was recommended to us by a sales engineer from EDB. I thank him for that, but that's definitely something that was causing us a lot of problems as well. And finally, most importantly, in the government spaces, you really need to think compliance first. I've always been a proponent of thinking test first, thinking security first, being able to build security and test into your process. Compliance needs to be part of that as well, and will be on future projects that I work on. Some best practices is to start simple. Getting started with Docker is really as easy as Docker run Postgres. And I'm going to show you that here in a few minutes. One master and multiple replicas. If you can get by with that, you're going to get a long way with Postgres. Have to talk about backup planning and recovery tests. There is something worse than not having a backup. It's thinking you have good database backups and finding out you don't. This is imperative because eventually everything will fail. Every hard drive will fail, every server will fail, and you need to have recovery plans in place. Small function-focused Postgres instances. Since these are small, they are well contained, and this is a method that is really promoted among the microservices culture, is to have your data live close to your application and have that scalable and small. Consistently use container security tools like Twistlock or Aqua Security. There's a number of them. We're currently using Twistlock, great tool, but it's very important, especially as hackers get more familiar with containerization in Kubernetes. You are starting to see some vulnerabilities in some events there. It's there's thousands of Red Hat vulnerabilities published every month. We're starting to see some here, and having a great container security tool like Twistlock has really been something. Been a great asset to this. But finally, people are key. Build the best team of the smartest people you can find. Lead with questions. And part of DevOps, which I'm involved in, is working very closely with developers, architects, test engineers, end users, product owners. It's all about eliminating that finger pointing, eliminating that blame game, and getting people aligned to work together and deliver value to the end customer. And finally, keep it simple. And speaking of which, we're going to get started with a quick little demo here. So in this demo, I'm actually going to install Docker. This is Fedora 29, which is the upstream version of Red Hat. There's also a product called Docker Desktop for Windows and Mac that you can use to spin up Docker on your host. Those do use a virtualization technology like Oracle's VirtualBox or Hyper-V. So we're just installing Docker here. And then there's a few things we're going to have to do after Docker's installed to get the process up and running. So if I just ran a Docker command right now, I would get an error because the Docker daemon is not running. So on Red Hat distributions, you're going to do a system control, actually sudo system control, start the Docker daemon. And then you're going to want to enable it as well, so it'll automatically start every time your VM, in my case, reboots. And this is a VM I've got running on my local host. And so now we've got our Docker daemon up, but there's no Docker containers running. So to start Postgres, it's literally as easy as Docker run Postgres. And if you don't want the latest version, you can actually specify a version. So this will give us the latest version of 12. If I would have said 11, I would have got 11.7. And Docker run does two things. It pulls the image and it runs it. You could do a Docker pull, then a Docker run, potato, and we're going to see now, okay, it's pulled the image, but when it goes to try to run it, there's an issue here. And if you look at the example, Postgres, this container was built to require a Postgres password. So that -E option is actually going to set the Postgres password when you run it. So you can set that to whatever you want. So I'm going to do a Docker run. -D will run it detached, so I can use the same shell for other things and not have to open a separate shell. So there's my password. I'm giving it vision, and I forgot the -E here, so let's put that in. And then you're going to tell it once again what you want to run, which in this case is Postgres 12. Okay, Postgres is up and running, and we can see that. We can see that on my port 5432 is mapped. The storage I'm using right here is ephemeral, which means it will go away. So obviously with a database, you're going to want to map volumes, which is a Docker, I think it's a -v option that you'll want to use to actually persist your data directory in Postgres. And then now we're just going to exec into this container. So the container name that the Docker daemon gives you is loving something. It randomly assigns these names. They're kind of creative. Or you could use the hash ID that's there to the left. And so I'm inside the container. You can see now I'm inside Postgres. And I can do, let's list all the databases. And you can see that's running. So literally 3 minutes to get Postgres up and running in a container. Doesn't get much easier than that. It's a long road ahead, though. I will want to say that containerization, Kubernetes, is a very deep product, deep technology to work with, much like Postgres is. So, yeah, this will get you started on your local host to harden this to run in production. There is some more work ahead, but even just for testing things out, you want to contrast Postgres 11 and 12. This is a great way to do it running locally. So the road ahead, containerize Linux. There's actually a container version of Linux come out from Red Hat called CoreOS. It's immutable, it has atomic updates, and it's doing virtualization at the OS level, which eliminates a lot of the needs for VMware. So this is really a preferred way to run containers. Like I said, there's not a lot of value added with virtualization in a container workload. Operators being able to use those more effectively to manage and update Kubernetes applications running in Kubernetes. Being cloud on-prem agnostic is really a key that we're working for here. And container analytics. So we've actually currently have 4 applications that are 100% containerized running in Kubernetes /OpenShift. And all of those are also using Postgres as their database. But there's some ancillary, somewhat legacy applications, and I'm very interested in diving more into Click and getting that containerized, or Tableau. And another thing too is pushing for real-time analytics. It used to be a lot of your OLAP versus OLTP confusion and barriers and ETLs was all around database performance. But with read-only replicas and containerization, it's very easy to get high-scale analytics running that won't impact your production workload. There are still needs for analytics. I'm not going to do what-if scenarios probably in my relational database. And some of these modern tools do produce really beautiful reports and outputs. So there's a lot of advantages to those. Also, I can't say enough about open source. I'm very thankful to the people that have worked on Postgres. I know a lot of nights and weekends went into this, and also very, very thankful to companies like EDB that provide people salaries to actually continue to improve Postgres and other open source technologies. And thank you to EDB for keeping open source alive. And then finally, microservices. This is the road of the future. It does move the complexity out of the monolithic application into the configuration, but it does have so many advantages around maintainability, flexibility, and microservices are showing up everywhere. And you look at some of the top performing technology companies on the planet, they're using this pattern, and very excited about it, and very excited to be speaking here today. So finally, does anybody have any questions?
Hey, so this brings up the nice Q&A portion of the discussion. Thanks so much for Jerry speaking about real-world examples of using containers in a production use case. My name is Bhavani Rao, and I'm going to facilitate the moderation of this session. So we'll start off with some easy questions and then get Jerry worked up in a sweat as we get into some harder questions. So easy questions. Asset properties. Are the asset properties of Postgres protected when you move to a Kubernetes environment?
Yeah, and that's actually the most difficult question. So thanks for starting with the hard first. I'm a little confused on this question because Postgres has been ACID compliant since 2001. But as far as the protected properties, I have not tested that. And back to test-driven development, I definitely want to do some tests around those properties to make sure it meets your requirements.
To my knowledge, I believe that the ACID Kubernetes shouldn't interfere with the ACID properties of PostgreSQL, but that's, like I said, I tested it. Yeah, okay. Fair enough. Let's move to the next question asked by Tioman, which is, and this is a question you've already kind of addressed in your discussion, but I think you need to do a deep dive, which is, how did you maintain database persistence, maintaining the persistence of the data for the entire lifetime of the database itself?
And this is a great question, because in the example I just showed, if you create some tables, start inserting data into your database, and you kill that container, all your data is lost. So this is a very good question. So what you want to do to start is use volume mapping, and you can do that when you spin up Docker containers. As you scale, there's technologies like Gluster that manage storage on the back end for you, can be mapped to Kubernetes. There's a lot of different options. You can actually even take NFS storage and map it directly into your container. But that's something that you will need if you want your data to live longer than the container, which is almost always the use case.
Great. So another related question from Shashant, and he asks, how is the performance of the database in a container with performance with a PV persistence volume claim? And then, do you recommend running production workloads with containers?
To answer the last question first, it depends, but I've been doing it for 4 years now. So under a lot of circumstances, yes, there's no one size fits all for everybody. So I think there are instances where you would not want to run the database in a container. We covered that earlier. Working backwards on the persistent volume and the performance questions, let's start with memory and CPU performance. Because a container is really just partitioned resources running on the hosts, there is negligible to zero impact on that. But what there is some overhead in managing containers. So that will require additional CPU cycles. That's part of the reason for having distributed clusters and distributed processing, is that you're not seeing the hit for that overhead, because a lot of the overhead, the Kubernetes controller can run on a different node than your actual database workload. And then finally, on storage, there's very little impact that I've seen. I haven't done a direct correlation to volumes, but you need to remember with Kubernetes, everything is software defined. So you've got software defined network storage and memory. And if you have no CPU, or if you have CPU starvation, even your I/O will suffer.
Great. So the next question is, why are you using OpenShift rather than vanilla Kubernetes?
Great question. Vanilla Kubernetes is fine. There's nothing wrong with it. It's what OpenShift is based on. For this particular application, in the government space, you have to have approved software. And so when you have OpenShift approved, it makes it a lot easier to bring something into a highly regulated organization. Also, OpenShift is a great introduction. It was a great way for my first exposure to Kubernetes. I played around with Minikube and Minishift, which actually is a great way to get started with both of these. But just getting into OpenShift, having a GUI, everything set up, everything integrated. Also, Red Hat OpenShift includes a lot, and they support that as part of the subscription. So you've got SSO included, you've got Jenkins included and supported, you've got RHEL on the host supported. So you got to buy RHEL if you're running Red Hat on the host. And now that they're moving to Core OS, because of that acquisition, it's really exciting what's happening with OpenShift 4.0 and what they're doing to, in my opinion, somewhat eliminate VMware, as we were talking about a little bit earlier. Also, they provide a trusted source for containers, so you can download a container from Red Hat, and pretty safe to trust it as much as you would trust anything else from Red Hat on the OS side, as opposed to just downloading images from the wild. As I mentioned earlier, I still highly recommend using a security scanning tool like Twistlock in addition to that, just to really secure, just to make sure that what you have running is reliable and secure. Also, they do vulnerability mitigation. OpenShift also, I had a slide that I actually took out. I kind of did the comparison of what OpenShift adds to Kubernetes, but there's secrets. There's a lot of different aspects you get with OpenShift out of the box. But there's sounds a bit like an OpenShift sales pitch, but there are a lot of good Kubernetes frameworks out there. And, roll your own K8. And for a lot of applications, especially if you're cost conscious, is a viable option as well.
Well, sounds good. Okay, this one you kind of addressed already, but it's more of a reiteration of what you've said, which is Srinivas asks, what are the top issues you faced with containerizing Postgres?
Yeah, pretty much as you said, I think the hardest issue, maybe to rephrase the question, what is the biggest challenge around containerizing Postgres? And a lot of it is the human factor. And, we had somebody very early try to shut down our whole containerization project who stated that, databases can never be containerized. You never containerize EDB. Here are all these blog posts on all the problems you're going to have when you containerize EDB. And, there are challenges, and a lot of those blog posts were written by, when you have new technologies, there's always people that are very incumbent in the way things are done. And either are making money off the way things that have been done in the past, or they're fearful of learning something new, both of which, or at least the latter of which we've covered earlier. So you got to break these fears down and really focus on, the technology and do proof of concepts. The proof is in the pudding, as the English like to say. And, there's obviously a lot of, you build momentum, you have some little successes and you grow, then people start trusting containers. And then if you go back and say, we're going to take your containers away and you got to spin up new VMs for everything. And, that's a very painful process to go back to. So it's definitely a point of no return. So you've got the barrier of empire trying to keep you from moving forward. Once you move forward, you've got the barrier of no return that keeps you from going back.
That's a great way to put it. Yeah, the people issues. Our next question is from Keegan Bantam, and this is a good question, which is, since Kubernetes has a self-healing function, how does something like streaming replication, physical replication play into this? I'm not exactly sure if he's asking if physical replication is a complement or is it contradicting what Kubernetes is able to do. So handle it any way you want.
I mean, self-healing is, Kubernetes goal, and there's actually something called the replication controller in Kubernetes, and its job is to keep everything that's scheduled up and running. So if you kill a pod, if you lose a VM, it's going to spin up another VM somewhere else, and that is the intent. As far as replication goes, streaming replication works inside containers just as it works on physical hosts or virtual machines.
Yeah, and I would add to it is that when the replication controller, it'll spin up another pod depending on whether there's resources on that cluster to be able to spin up that. But with streaming replication, you always have that available. You have another redundant replica of the database at your command at any time. So anyway, let me keep going. Shashant Parwar asks, earlier I've asked with change in container version resulted in YAML syntax change causing the YAML compatibility issue. How to resolve it? This was not phrased as well as it could. I'm wondering if you could try to decipher what is being asked.
Yeah. YAML, if you're new to YAML or JSON, it's not very tolerant of syntax errors or changes. So, there could be some updates you have to make to your YAML configurations. And Kubernetes is YAML or JSON driven. I think internally it uses JSON, but pretty much everybody uses YAML on the outside, and you can convert back and forth. As far as troubleshooting that, I would just maybe break it down to its lowest life form. Start simple and try to really isolate what the change is that's causing the issue.
Okay, sounds good. Next question is from Mr. Joshi, who asks, is your code available as open source project?
I would love to open source more stuff in the public sector, and I know that the public sector's goal is our default to open, but not currently.
Okay, great. We have one last time for one last question, and that is, Are you using containers in production? Was there any pushback to that?
Yes and yes. Fortunately, our tech leads and everybody on our team had experience with containerization before, so that made it very easy. But there's always some pushback. But we have been running containers. I've been running containers in production for 4 years now.
Awesome. Okay, well that brings us to the top of the hour, and I loved hearing this whole story on the use of containers at a U.S. government facility, U.S. government agency, and I hope that everyone learned something on this call, and I hope that you enjoy the rest of Postgres Vision. Thank you for attending.
Thanks, everybody.